Good Holy. Today I am going to explain one of the most important concepts of operating systems, the processes, threads, and context switching. So you can think of a process as the computer's multitasking ability. Kung walang process, yung modern operating system, hindi siya mag-work. So we will look at what a process is, its different states, kung paano nag-operate, nagmamanage yung operating system, and I will also provide some real-life analogies to make it easier to understand, and I'll also show some simple C++ pseudocode that demonstrates how processes work. So, what exactly is a process? A process is simply a program in execution. When we say program, meaning it is a set of instruction that is stored on a disk, like a text editor, a web browser, or even a simple calculator. But a program that is on a disk is not alive. It only becomes a process when the operating system will load into the memory and starts running. So para siyang recipe written in a cookbook. So that recipe written in a cookbook is just an instruction. But when a chef actually cooks it in the kitchen, that is what we call the process. So similarly, a program is static while a process is active. Technically, ang process, it includes the program code, ito yung text segment, yung data that the program will use, yung current state of the CPU registers, and also a unique identifier that we call PID or process ID. And most importantly, a data structure maintained by the operating system that is called the process control block or PCB. So yung PCB para siyang record card na nagtatrack sa lahat ng anong nangyayari sa loob ng process. So kung saan siya, where it is in memory, what it's doing, what files it's using, and so on. So a process isn't always running. Nag-move siya in a life cycle of different states. Meron tayong different states. So the first one is yung new na state. This is where the process is being created. So for example, when you double-click on an application, yung operating system will start building the process structure. Next is the ready state. The process has all the resources it needs except sa CPU. So it's in line, waiting for its turn to execute. The third one is the running state. Since the process is actively executing the instructions sa CPU, only one process per CPU core can be running at a given time. The next one is yung waiting or blocked. So sometimes yung process, they cannot continue because it's waiting for something. So for example, they are waiting for an input from the user, or a file to load, or a response that is from the internet. And lastly is the terminated state. So this is where the process has finished its execution and is removed from the system. So yung operating system, siya yung nagko-control to all of these transitions. For example, if a process is waiting for a file to load, then yung operating system magmo-move siya into the waiting state. And later, when the file is is ready, it moves back to the ready queue. So operating system is very important. It has a central role in managing these processes. So ito yung ginagawa niya. So first is process creation and termination, just like what I said earlier. The OS will create processes when requested and then cleans them up when they're finished or when they're done. Next is scheduling. Since maraming mga processes nag-compete for the CPU, ang OS siya yung magde-decide who gets to run next. So, this decision is nag-base siya on scheduling algorithms like round robin or priority scheduling. And the third one is memory management. Yung OS, siya yung nag-make sure na lahat ng process has access to its own memory while isolating it from others for protection. And then we also have inter-process communication or DIPC. So sometimes yung mga processes, they need to talk to each other. So yung OS siya ay nagpo-provide ng mechanisms like pipes, shared memory, or sockets for the processes to exchange data. And we have protection and security because processes, they cannot just peek into each other's memory without permission. So, yung OS, siya yung nagsiset ng o siya yung nag-i-enforce ng boundary which is important for stability and also security. Now that we have understood processes, let's move on sa threads. So, since processes are heavyweight for multitasking, then threads are lightweight. Threads are smaller, faster, and they are more efficient. So sometimes tinatawag siyang lightweight process because they allow multiple tasks to happen inside a single process. So a thread is the smallest unit of execution within a process. So every process must have at least one thread. So, yun yung tinatawag nating main thread. But, yung mga modern programs often create multiple threads to handle different tasks at the same time. So, ang pinag-iba niya sa process, threads share most of the resources of their parent process. They have the same memory space, the same open files, the same global variables, but each thread still has its own private data. So a stack for function calls and local variables, a program counter that tells it where it is in the execution, and it has its own registers. So, think of threads as para siyang independent workers inside the same office. They share the same space, but they are doing different jobs simultaneously. So, the operating system is heavily involved sa pag-manage ng threads, though it depends on the type of threads. And actually, there are two major types of threads. We have the user level threads. This is managed by libraries, user space, and then the OS doesn't directly know about them. They're lightweight but may suffer if one thread blocks. And the next na type is yung kernel level threads. The OS knows and schedules them individually. So these are more powerful, but they are slightly heavier. So threads are everywhere in real-world applications. So a great example of this is in a web browser. So one thread might handle rendering, while another thread might handle network downloads and another might play audio. So now that we have learned about processes at saka threads, we also need to understand kung how the operating system gives each one a fair share of the central processing unit. So, dito mapasok si context switching. Context switching is a fundamental technique that allows multitasking. So, it lets the computer pause one task and switch to another. So, multiple processes and threads can appear to run at the same time. And then, ang context switch, so this is the act of saving the state of a running process or thread so that the CPU can load and run another one. The context, from the word itself, context switching, it refers to all the information that the CPU needs to resume execution later. So, this includes the program counter kung saan where the process left off, the CPU registers, the stock pointer, and in the same case of processes, memory management, information like page tables. So, importante yung context switching for many reasons. So, first is multitasking. So that you can, for example, you can browse the web, you can listen to music, and you can also download a file at the same time. Next is responsiveness. So, for example, if one task is waiting for the input-output, then the CPU can switch to another task, so instead of sitting. Next is fairness. So, yung scheduling algorithms na mentioned earlier, like yung round robin, this ensure that every process gets a fair share of CPU time. So, the question is, how does the operating system perform a context switch? So, let's discuss it step by step. The first thing to do is to save state of current task. The operating system saves the program counter and the CPU registers into the current process PCB, the process control block, or threads TCB, thread control block. Next is to update process state. So, yung operating system, siya yung nagmamark sa process as ready or waiting, depending on why it stopped running. And the third step, it chooses next task. The CPU scheduler will select the next process or thread to run based sa scheduling policies like round robin, priority, or short job first. And the fourth step is it load new task state. The OS restores the saved registers, program counter, at saka stock pointer from the PCB or TCB of the next task. So, if process siya, it may also switch memory mappings. And the fifth one, lastly, it resumes execution. The CPU continues execution from where the new process or thread left off. Now let's talk about the comparison table of the process and thread. So, processes are like separate programs that run independently, while the threads are smaller workers inside the process. So, yun yung analogy. For the memory, we all know that processes don't share memory, so it making them safer, but they are heavier. Yung threads, they share memory, making them faster, but they are prone to errors if they are not managed carefully. In terms of communication naman, since processes are isolated, So, kailangan nila ng special mechanism, like kailangan nila ng pipe, sockets, or shared files. And the threads, they talked directly since they all live in the same memory. For isolation, if one process fails, well, others continue. But when we talk about thread, if one thread fails, it may bring down the whole process. So in terms of overhead, processes are heavier for the operating system to manage. Meanwhile, yung threads, they are lightweight and more efficient. So processes gives us safety and stability, while threads, they provide, since they are faster, they provide speed and efficiency. So yung OS, they act as a manager. They balance both the process and thread through context switching. So in a real world software, for example, you can use process when isolation and reliability matter, like when you're running independent apps. Use thread naman when you need speed and parallelism, so inside one application. For example, web browsers or games. So yung power ng modern computing, this lies between combining both process and threads, with the OS ensuring smooth execution.